As we said in the last section, if you want to melt a substance, you have to add a certain amount of heat, the heat of fusion. You can find the heat of fusion of water on reference table B. It's 334 joules per gram. If you want to find out how many joules it takes to melt a certain amount of ice, it's easy. On the back windshield of your car, you may have noticed that there are horizontal lines going across it. You might think this is your car's antenna, but you'd be wrong. These wires here are heating elements, and what they do is they heat up in order to defrost your rear windshield. You can also use it to defog your rear windshield. You push this button right here, these heating elements heat up and add enough heat to get the ice to melt. The heat of fusion is the amount of heat required for every gram of substance you have to either remove it from a liquid to freeze it or add to a solid to melt it. So for example, if I have 55.7 grams of water and I want to melt it, first I have to bring it up to 0 degrees Celsius. That's why I have the 0 degrees Celsius here. It assumes we've already brought it to the melting point. What we do is we take the equation Q equals mass times heat of fusion. The mass we're trying to heat is 55.7 grams times the heat of fusion of water is something very nice. Take away 334 joules per gram and what you get is ice. Grams cancel and leaves us with 18,603.8. Now, of course, sig figs apply. 3 sig figs, 3 sig figs, boom, boom, boom. 18,600 joules. And that's how many joules it will take to get 55.7 grams of water to melt once you've heated it to its melting point. Let's say we've cooled some water down to the freezing point, and now we want to freeze it. And we've got 143.2 grams of water to freeze. We'll put it in the freezer. Q equals mass times heat of fusion equals 143.2 grams times 334 joules per gram. Again, you're getting this from reference table B. You don't have to memorize it. 47,828.8. Once again, 4 sig figs, 3 sig figs, we want 3 sig figs, 47800 joules, because grams cancel out. And that's how you find out how many joules it takes to melt or freeze water. You can only use 334 joules per gram for water. Every substance has its own unique heat of fusion. If you're ever asked to find out for any other substance, you'd have to be given the heat of fusion. Heat of vaporization is the amount of heat it takes to boil water, or the amount you have to remove from water vapor to get it to condense. The heat of vaporization is 2,260 joules per gram, and again you find that on reference table B. The equation is Q, the amount of heat, equals mass times heat of vaporization, just like for heat of fusion. It's the amount of heat required for each gram of substance to either be removed from a gas to condense it or to be added to a liquid to boil it at the boiling and condensing point. So it's going to assume we've already gotten it to the point where it's going to undergo the phase change, 100 degrees for water. So how many joules are required to completely boil 152.4 grams of water at 100 degrees Celsius? Q equals mass times heat of vaporization equals 152.4 grams, that's our mass, times our heat of vaporization of 2,260 joules per gram. Say goodbye to grams. And this equals 344,424. 4 sig figs, 3 sig figs, 1, 2, 3 sig figs, 344,000. 344,000 joules to get the job done. Notice this number is so much bigger than it was when we were doing heat of fusion. Why? Because heat of fusion is only 334. Heat of vaporization is like 8 times as big. So you're going to be dealing with much bigger numbers when you're trying to boil water. They say a watched pot never boils. Now you understand why.